In this video, we are going to look at how FastAPI handles database access the right way, asynchronously. You will learn what an async driver is, how SQLAlchemy's async session fits in, and exactly why mixing sync and async database code is a trap you want to avoid from day one. FastAPI is built on an async event loop, the same loop that handles every incoming request. When you call a synchronous database driver inside an async path operation, you block that loop completely. No other request moves forward until your query finishes. With 10 concurrent users, that is tolerable. With 1,000, it is a bottleneck that erases FastAPI's performance advantage entirely. Think of the event loop as a single cashier at a busy cafe. With the synchronous database call, that cashier disappears into the kitchen and stands there watching the espresso machine. Nobody else gets served. With an async call, the cashier hands off a ticket and keeps working. The database signals back when it is ready, and the cashier picks up the result without ever having stopped moving. There are 4 moving parts. First, an async driver asyncpg for PostgreSQL or aiosqlite for SQLite replaces the blocking C extension with a non-blocking one. Second, SQLAlchemy's create_async_engine wraps that driver into an engine. Third, async session is the session class you use to run queries, and every call on it must be awaited. Fourth, your FastAPI path operation must be declared with async def, so the event loop can pause it while the database does its work. Starting at the top, create_async_engine receives a URL that uses the SQLite plus aiosqlite scheme. That plus sign tells SQLAlchemy which async driver to load. Next, async_session maker creates a reusable session factory tied to that engine. The item model is standard SQLAlchemy. The get_db function is a FastAPI dependency. It opens an async session using async with, then yields it, so FastAPI can inject it into the path operation and still close it cleanly afterward. Finally, the path operation is async def, so it can await db.execute. The select call builds a SQL select, execute runs it against the database without blocking, and scalar_1_or_none returns a single item or none. When a request arrives, the ASGI server hands it to the event loop. FastAPI resolves the get_db dependency, opening an async session. The moment your code hits await db.execute, the path operation is suspended. It is paused on the event loop schedule, and the loop is immediately free to handle other requests. When the database driver signals that the query is done, the loop resumes your function, the session closes automatically via the async with context manager, and FastAPI serializes the return value into a JSON response. Reach for async database access when your API expects real concurrency, and you are already writing async path operations. The two must go together. It also shines when a single request does multiple I/O operations, like a database query followed by an external HTTP call. Skip it when the app is low traffic, when your driver has no async support, or when your team is not yet comfortable debugging async code. A sync session accidentally used inside an async path operation blocks silently and is painful to trace. 4 things to lock in. 1. The async driver and the engine URL scheme must match SQLite plus aiosqlite or PostgreSQL plus asyncpg. 2. Deliver the async session through a depends dependency, so the session lifecycle is managed for you. 3. Your path operation must be async def, and every query must be awaited. 4. Never drop a synchronous session into an async path operation. It compiles fine, but silently stalls the event loop under load.